Welcome, sir. Our brand has the most efficient car in the world with all top features available. Is it? I know that Carnot engine is the most efficient engine in this world. Does the car work based on Carnot cycle? Let me take you through a thermodynamic explanation of what could be the maximum efficiency of an engine. Carnot cycle is a theoretically construct most efficient thermodynamic cycle. In this video, we will get to know about the various processes of Carnot cycle. Isothermal expansion. As you can see here, the heat is added from the hot sink to the cylinder. Thus, the cylinder does work on the surrounding by pushing the piston upward, allowing the gas to expand. The PV diagram of the isothermal expansion process indicates the reduction in pressure with an increase in volume. It can be inferred from graph 1 to 2. The TS diagram shows that the temperature remains constant and there is an increase in entropy indicated by the straight line between points 1 to 2. The second process in Carnot cycle is adiabatic expansion process. The gas in the engine is thermally insulated from both hot and cold sinks. Thus, it neither gains nor loses heat to be an adiabatic process. The gas continues to expand by reduction of pressure doing work on the surroundings and losing an amount of internal energy equal to the work done. This is an indication of reduction in pressure from points 2 to 3 with an increase in volume. The gas expansion without heat input causes it to cool to the cold temperature TL with the entropy remaining constant. That's what's shown in points 2 to 3 of the TS diagram. Isothermal compression. Expansion process is done. Now compression starts by rejection of heat. Now the gas in the engine is in thermal contact with the cold sink of temperature TL. The surroundings do work on the gas, pushing the gas down, causing energy Q out to leave the system to low temperature sink, and the entropy decreases. The PV diagram indicates in points 3 to 4 that there is a drastic reduction in volume, thus increasing the pressure. In TS diagram, since the process is isothermal, the temperature remains constant with decrease in entropy from points SH to SL. Adiabatic compression. Once again, the gas in the engine is thermally insulated from hot and cold reservoirs. During the process, the surroundings do work on the gas, pushing the piston down further. This leads to an increase in internal energy and rise of temperature. From the PV diagram between points 4 to 1, it's observed that pressure increases with decrease in volume. From the TS diagram, it's observed that entropy S is constant and the temperature alone increases to TH from TL, thus reaching the initial conditions making the process a cycle. Here's a happy man driving his car. Leave him and let's do a small math on his car if it is run on a Carnot cycle and find out its efficiency. These are the inlet and outlet conditions of heat and temperature. The formula for the efficiency of Carnot cycle is ratio of internal energy of cold sink by internal energy of hot sink. Plugging the values in the equation, the efficiency is equal to 0.8 and efficiency achieved only in a Carnot cycle. Now, are the most popular cars in the world being run in a Carnot cycle? The answer is no. Here is a real situation. A bicycler would overtake your car if it is run in a Carnot engine. The reason is, as we have seen, the heat is added and rejected at isothermal processes, means keeping the temperature constant. That is, the Carnot engine will be too slow to transfer heat without any change in temperature. That is why the Carnot cycle is only a theoretically constructed benchmark thermodynamic cycle. To make studying simple, prepare your UPDA exams through our e-learning website www.updatraining.com. For daily question and answer flyers, follow our LinkedIn page UPDA Training Qatar. Subscribe our YouTube channel UPDA Training for more interesting videos.